knows a lot about the science stuff. Professor Dave explains.
For a few decades now, we have been studying star systems in our region of the Milky Way, and we have discovered many exoplanets in the process. Particular interest is paid towards finding roughly Earth-sized planets orbiting within the habitable zone of their star, which means the band of orbital distances within which liquid water can exist on the surface of the planet, a range that depends heavily on the size and temperature of the star. We now know that a number of star systems in our cosmic neighborhood harbor potentially habitable worlds, and this is a notion that captivates the imagination. Could these worlds already harbor life, perhaps even intelligent life? Of course, we can only speculate for now, but we will continue to learn about these systems in the meantime. Let's take a look at one such system now, called Gliese 667. This is a triple star system, just like the Alpha Centauri system we learned about, but it's a bit farther away, lying in the southern constellation Scorpius, about 23 light-years from Earth. Gliese 667a and b are around 13 astronomical units apart, forming a binary system, and they are both quite similar to our Sun, being K-type main sequence stars with around 70% the Sun's mass. However, they are much lower in luminosity, around 13% for A and 5% for B. Then, gravitationally bound to this first pair at a distance of around 230 astronomical units, we find Gliese 667c. This is a red dwarf star with only 30% of our Sun's mass and a little over 1% the luminosity. This star is the most interesting of the triad because of its planets. We believe there may be up to 7 of them, 2 of which have been confirmed, and 1 of which is believed to be quite Earth-like. The ones that have been confirmed are called Gliese 667cb and 667cc, while D through H may also exist. All the planets, both confirmed and unconfirmed if they do exist, orbit very close to their star, as we can see here with our innermost planet Mercury's orbit shown for comparison. As for the confirmed planets, 667cb is the more massive one, with at least 6 Earth masses and potentially up to 12. This one orbits very close to its star, too close to be habitable. 667cc is a bit smaller, at a little under 4 Earth masses, qualifying it as a super-Earth, making it once around its star every 28 Earth days. This planet does sit in the habitable zone of its star, receiving about 90% of the light that Earth does, and allowing for the possibility of liquid water on its surface. Like other planets that orbit so close to their star, it is likely to be tidally locked, with one face always towards its star, which would reduce habitability, since one side would be very hot and the other side would be very cold. But if the atmosphere is thick enough, this can allow for sufficient heat to be transferred to the far side, and there is also the possibility of habitability being restricted to the terminator line separating the day and night halves of the planet, where one could bask in endless twilight. Planets like Gliese 667cc inspire us to continue our search for other Earth-like, potentially habitable worlds. Our fascination with these worlds is undoubtedly a manifestation of our desire to one day walk upon them and tap into the seemingly limitless potential of our galaxy. What a transformation it would be to leave the cradle of cosmic infancy that is our little planet and enter an interstellar adolescence of adventure. Will we visit these worlds and others? And what might we find if we do? Only time will tell.
Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.